Aloha, this is Richard Halverson, ITS148. Today is Tuesday, January 26th. And so let me share my screen. Let's look at the syllabus and share my screen, screen number 2. All right. So we are in today is the 25th, 26th. So we are in this week, week 3. So we're going to start chapter 10. All right, and that's on exceptions. And let's see, I think we skipped over exceptions last semester. Okay, so if we go to our textbook, let's go to the beginning of the textbook here. So we are in chapter 10, exceptions. Okay, so exceptions are some code that you can add where you can flag errors. So that's what we're going to talk about today. So in Python, and so we have the error checking code is when the programmer introduces it's code that the programmer introduces to detect and handle errors. Let's see. Let me put this in present mode. That's better. Python's construct is where, see, this shows an example without exception handling, and you read in some information. Okay, so you ask for the weight. You ask for weight in pounds, and the person enters this. So the error occurred on line 3, which is this line. And this was the statement that was executing. And so this here is the Python, like the Python runtime machine that detected the error and made it so your program bombed and you know, it couldn't continue. But if you wanted to control that, if you wanted to control these errors, then you can write some code to capture to capture that exceptional condition, and then you write code to do something about it, and then your code can continue. Okay, so here, if somebody types in something wrong, then the code that normally would be executing is stuck down here, is done inside the try. Inside this, okay, so the construct is try and accept. And so the code that you're normally going to run is inside the try part. So you're gonna so instead of just running this code, you're gonna try to run the code, because it's possible that the person's not going to type in something that can be converted into an integer in both these cases. Okay, and if that happens, then the thing blows up. And so so instead of it blowing up and printing out this error, instead what happens is it bounces out into the accept part of the construct of the statement of the code, and then this executes. It says, sorry, we can't calculate your health info, and then it quits. It doesn't go back and continue or anything. It's done. It exits out of the try part and goes down to the accept part and executes that code, and then it's done. Okay, so then in this case it would continue with the loop, in which case this would execute and go back and start the while again unless somebody types in a Q. So anyway, that's how the accept works. So this is the construct. It's try, and this is the normal code. But then what you do is you have this accept part afterwards, which is what executes if if something exceptional happens inside this, something that would cause the program to bomb. And in this case, it is trying to convert something that's not digits, it's not a string of digits, trying to convert that into an integer. If it's got some other characters in there that are not just digits, then it just bombs. It prints out the error here. And so what you're doing is you're capturing that and handling that error so your program can continue to run. All right. So this explains how it works, and you can click on the speed here and you can see first it tries, and if there's an error, then it doesn't execute the rest of this code. It just goes to the except part. You can have multiple exception handlers, and there you identify what's sort of what the cause of the exception was. There's different types of exceptions, and so you know, your code can be, your try code can do all kinds, can do things that could cause, if things go wrong, if the user is not cooperative, can cause the program to, normally it would bomb, but you can handle that exception. So that's how you do that. And so let's see what this one looks like. This is the demonstration of it. I haven't gotten my points yet. Okay, so it goes along, causes a type. Okay, causes a type error. Got it. Okay. Right, sure. So something happens which causes this type of error, and then it jumps to the exception handler for that. So here's one that's got multiple exceptions for a value error and a divide by zero error. All right, that's nice. Okay, here's a challenge activity. All right. I think we're going to get through this whole chapter today, so I can pause and do this challenge activity. Let's see. Let me open up the chat just in case. Okay. So type the program's output. Okay. So it's here the input. Okay. This thing executes. You gotta follow the Python code correctly. This thing executes and gets an input, and if it's not equal to end, then it tries to do this, and it converts that input to the divisor, and then it's going to take 60 over the divisor. 60. Value error would be if divisor was, if it was, well, let's see what happens. Okay, so 2, that's one input. Okay, then 60 divided by 2 is 30, so that's output. And then, these are getting complicated. Okay, and then it comes, then it asks another input, and it's 1. And then it comes back around, and divisor is 1, so 60 divided by 1 is 60, that's that. And then somebody types in FOUR, and that causes a, I guess it causes a value error. So so value error, so it outputs the V. And then comes back around and someone types in a 0. And so this is going to come back around, and so it's going to convert the divisor into the number 0. And of course, we can't divide by 0, So it causes a 0 division error. This is a key word, must be. And so it outputs the Z here. And then somebody types and it's done. Okay, so that's what that one does. Let's start this one. Boy, that's pretty complicated. Okay. 5, that's a value. That's going to be, it's the same code. It's the same code, isn't it? Yes. So 5 causes a value error. And so it's going to print a V. And then the 1 is fine. 1 is going to be 60. I remember that. And 2 is going to be 30. I remember that also. 0 is going to be this 0 division error. So I remember that too. Z. And then end. And it says, okay. Boom. All right. Is that right? Yeah. Okay. Okay. What's the next one? Ooh, boy, this looks more complicated. Huh. All right. So the first one is, it's, okay, what are we doing here? There's numbers. We keep on going till we get end. And when's the first time we, okay, the first thing we do is we convert it into an integer. So it's got to be a number that you convert it to an integer. And then compute. Boy, this is a hard one. What is, I don't, is a divisor ever greater than 0? Yes. The divisor is greater than 0 or greater than 20. It is here. Name error. Is that? That must be the error. Okay. Numbers divisor. Oh, that's going to be an index error, because if this is an index, this is just a simple list or an array. It will be called an array in any other language. And so divisor's got to be 0, 1, 2, or 3. And so divisor is what the input is. So that's going to be, okay, but this is only going to execute if the divisor is less than 0. See, we're forcing an error here. We're forcing an error. Otherwise, the result equals 20. What is result? I see. Oh, I see. Okay, anyway, let's see what this is. 33 is going to be 33 is integer 33. Divisor is greater than 20, so it should cause this name error. The name error is S. Okay, let's see. And then the second one is 2, and 2 is going to be result equals 20. Print result. And then do a space. Okay, 20 space. And then it's going to enter a 0, and 0 is not greater than 20. 0 is not less than 0. 0 is so then this is executed, and so it's going to be result. It's going to be 20 again, I guess. Weird. And then it's -2, and -2 is less than 0. So it's going to try to find the -2 element of the numbers array, which of course doesn't exist. It's got to be a 0 or greater. So this is going to cause a value error, I guess. It's the value error. So I'm gonna say it's R, and then enter. And then it's going to do -6, and the same thing should happen because it's this thing right here. So I'm going to do R again. This is crazy. And then I'm going to say 10, and 10 is a oh, whoops. R is index error. It shouldn't be index error. What's index error? It's S. So this shouldn't, sorry, this should be S, not R. Yeah, R is not value error. I mean, if it's -2, it's S space, S space. And then after that, the 10 causes the value error. Oh, that's right. There's Jesus. That was really wrong. Okay, so that causes the value error, which is that, and then end. Which is okay. Yes. Jeez. Well, I'm just gonna okay, 33. 33 causes the. Yeah, I gotta see if this is right. Okay, no. This ends at 33 causes the S. So this should be like that. Okay, 33. Yeah, 33 causes the name error. And then 2, result is 20. 0, result is 20. -2 is an index error, which is S. -6 is an index error, which is also S. TEN is a value error, which is R. And then you type in end, and it skips out and prints OK. Let's see. It should be 10. Oh, I didn't see this. I wasn't paying attention to that. So this should have been divided by what the divisor was. And then it should have been an R. The third one is, because the divisor is 0, right? So that's a division by divide by 0. Okay, so that's okay. All right, so that's wrong. Yes, okay, good. All right. So yes, Aaron, I will do that after I get through this challenge exercise. Okay. 10.2. Oh, this. Oh, you're saying, can you run? Yeah. Yeah, you can do that. Gosh, somebody's.
Yeah, some of these get really complex, and as a beginner, it would really help if I could copy and put it into the test PY to see what's going on.
Yes.
So I can get a better beginner's understanding, if that's allowed.
Well, yes, it's allowed.
Okay.
Absolutely allowed.
Okay.
You just have to be smart enough to do that, to think to do that. And somebody here is and somebody here isn't. So I'm just going to copy this code for the rest of you. Boy, yeah, this is getting kind of hard. Okay, so this is going to be that, and I'm going to save this as desktop test.py. How's that? All right, so this is the code. It's not this. I'm going to put this someplace else. And let me make this like this. Oh, that's why that. Okay, so this is the code. Oh, wait a minute. It's, well, it's, okay. Okay. I just need to know what the input is. All right. All right. So let's run it. Okay. Bring up my thing. If that's allowed. How would I enforce it? Or, how would I enforce it? I wouldn't be able to enforce it. And you can't have, that's not the, can't have a rule like that. You have to realize that people are going to do that. And, anyway, let's CD desktop py test.py. Okay, it's
I've never tried it, and I downloaded the Python program, but I need a new computer, so I've never tried it, so I don't know.
Okay. Let's see, how did that? I got to figure out how that happened. How did line 32? Where? All right. Oh, I don't know. Okay, so let's try this again. Okay, now it's asking for input. Good. 33. Good. S. 2 is 10. Interesting. Yeah, so you have to be smart enough to know what's going on here. 10. That's. I entered the 2. Oh, okay, I see what's going on. Now I type the 0, and now I type the -2, and now I type the -6, and now I type the 10, and now I type the end. Okay, so you have to look down S10R5SR. Okay. Right, so that's the answer. And it says here, S10R5SR. Okay. All right, so let's, very good. Let's do this again. Next, okay, I'm still on that one. What's different about this one? Is there anything different about this one? I don't know. I'm gonna copy this. Copy. I'm gonna paste it over here. Select all. Paste. Very good. Save this. go here, run it, and then I'm going to go 33, enter, 2, enter, 0, enter, -2, enter, -6, enter, 10, enter, and enter. And I get 33. No, I get S, right? Starts with S, right? Must. S space 10 space R space 5 space S space R space OK. Enter. All right. Does that look right? Let's see. S10 R5 SR. OK. All right. Check. All right. Okay. All right. Let's just see what the next one is.
What version of Python are you using?
3. So I can go PY and I go oops. PY and it tells me it's version 3.0. Now I tell you, should I try to run this with version 2? Because I have version 2 also.
I just found 3.9.1 for the update.
Yeah, that's a good one. That's the one. Okay. You should use 3, at least the 3, because that's what this book is. Very good. Okay. All right. So I just want to see what the next one is. Oh, this is the next one. Oh, it's a little different. Well, I tell you what, class, you do the same thing that you do Aaron's idea and do the same thing, and you should be able to get the answer. And you can rewind this video back and see what I did before. But basically, just copy this into your test and run it, and you should be able to figure out the answer. Okay. Anyway, so great. What's next? Raising exceptions. So here's the BMI example, which figures out your BMI based on whatever your weight and height is or whatever. And then with error checking code, but we did this manual error checking code, which does not consider, it doesn't look like it considers if the person does not type in an integer, because it considers weight as less than 0, that's invalid. Yeah, same thing. So instead of printing out invalid weight like this, you can write code that will actually raise the exception. This value error code, you can raise that exception yourself with code, and that way, if you're going to write, if you're going to have exception handlers in your code, you can take further advantage of them by sort of making all of your error handling code just be an exception. So you raise the exception, and later on we'll see in this chapter that you can create your own classes of exceptions. And so like any of the business rules or whatever that you have that you have to code in, you know, because of the particular application or you know that you're doing, you can code in those as actual exceptions to handle and be able to handle them better, to more all in one place. All right, so here's how you might do this, where if somebody types in something that's not an integer, well, that's wrong. But in your application, if they type in a minus number, that's an integer, but it's not a correct way as far as your application is concerned. So instead of, so what you can do is you can raise this value error exception, and then outside the try, and so that's, you can handle it where you have the same value error exception raised in both cases for weight and height, but the message is different. And so it print here we see it prints out where somebody types in invalid height, and so it's this one that runs, and here they type in invalid weight, and this one is raised, and this is where it's printed out. So this as keyword is how you grab out the name. As keyword binds a name to the exception being handled. Okay, so here's another challenge activity, and so let's see if this let's see if this cheating way works again. I guess if you're going to go through the trouble, you know, you really should try to figure it out on your own first, because that's how you can, you know, you're emulating the way the, you know, you're stepping through the logic of your code, and it's, you know, basically your desk checking code. But let's see if this way works for this example. Okay, so here the person types in 10, and here for an age, and if the age is less than 0, raises invalid age error, which is this. Otherwise, it takes 220 minus your age, and that's what your heart rate should be, I guess. So 10, yeah, okay, so great, start. So if it's 40, your age is 40, you should output 180, I guess. I'm going to output a AVG space 180. Enter. Next, this is going to be an error, so it's going to print out error space except is invalid age. Enter. Right. So anyway, that's that one. Let's move on. Exceptions with functions. Okay, so here, here's an example of an exception handling constructs along with functions. So inside functions, you raise the exception handler, and you raise exceptions, and that's passed out to the because it's inside, because the function is called inside of a try. So inside this try, the function this function is called, and this function is called, and so if an exception is raised in this function, okay, and it's not handled in here, you can handle it in here if you want to, but if you don't, it gets passed out, and it gets, it's going to get passed out to the exception handler of the try. You could have another try inside here, but that's not this. All right, so here for example, this function is called get height, And this exception handles down exception. This error occurs down in this function, and so it bounces directly out to where the exception handler is for the try that it was executing in. It was executing in this try, so it jumps out to this exception handler, and this is where that's displayed. There's also a cleanup component to this try except, and it's called finally. It's different names and different languages. Finally, where no matter what happens, the finally is executed. Now that's the same as it seems to me like you don't really need the finally because you can just have the code after that. But in sort of a structured way, it's not it's not as elegant, and since this whole try except finally is like one unit that does something, and so you could leave the finally out and put it afterwards. So after this try except, then it's going to just jump out and execute this code anyway. But this sort of keeps it contained and together and so on. So that's what the finally does. And you can create your own exception types by creating a class based on this exception, based on the exception, built-in class. Let me exit the view here. Custom exception type. It inherits. It's creating a class which inherits from the built-in exception class. So that's what that does. And so here, so you create a class called less than zero error, and so you can raise this less than zero error that you created, and so that would cause and if that's not handled, it's going to cause the error to occur out here, and cause the program to bomb if it's not handled. So that's pretty interesting. So that's pretty cool. All right, so let's go to this first exercise here, fat burning, the fat burning heart rate, and we're going to throw in some exception. Okay, so let's see what this is. Write a program that calculates an adult's fat burning rate, which is whatever this is. Inputs this fat burning. Okay, so this is what it looks like. So you got this age, and you got to write. You got to write this whole function. Looks like you do. And then you have to write the code here to call age. Okay, so this to do, modify the call get age and fat burning heart rate and handle. I'll modify this to call this. Okay, so something like this. Okay. All right, so really what we want to do is we want to get the age, and then we want to get the heart rate, fat burning heart rate, which is this. So we get the age, and then we calculate the fat burning heart rate of the age. And then we print the fat burning BUR heart rate for a blah blah year old is heart rate that I just calculated beats per minute. Right. So it's 70% of 20 minus the person's age. Okay, so and that's what the is. And it's got to be in this age range. If it's not in this range, then this error is raised in this method as an invalid age. And handle the exception out here. So you handle the exception outside there, but these errors are raised in the methods. I mean, you know, in these subroutine methods here that you've created. Okay, so so we get the age, and okay, so the fat burning heart rate is here. Here we're going to return. Let's calculate the heart rate. And that's going to equal to 220 minus the age, which is passed in, times 70%. And that would be 0.7 times 0.7. Okay. And then we return the heart rate. Okay, and the age is going to be correct. We don't have to worry about the age being wrong because that's going to be handled in here, the age being wrong. So let's say the age is read in, and we're going to raise a value error if the age is outside that 18 to 75 range. So if the age is less than 18, or the age is greater than 75, then we want to raise this exception, raise a value error exception. And I'm going to say invalid age. And that's going to be, otherwise, we're fine and we just return it. Okay, so, the way this works now is first we get the age, and if it's outside the range, it raises this exception. Otherwise, if it's fine and dandy, it calculates it here and prints it out. Okay, so is that the only exception there is? Yeah, I think it is. Okay, so I'll tell you what, I'm gonna go out here. Oh, I got this development mode in there. Okay, so I'm just going to use this development mode thing down here. Okay, so I'm going to run it. What happens if I run it? It says, looking for no output. Okay. End of file arrow. I could put an exception and end of file exception. That's interesting. I could do that, couldn't I? Anyway, I won't. If the age is 20, then I get that. If the age is, what does it say up here? 35, then it says that, but 17 doesn't work because, okay, so I didn't put my exception handler. I haven't put in my try catch in Visual Studio. In C# it's called try catch. Might be called that in Java. Anyway, so let's do that. So we'll put a try. What's the format of the try? Try : indent. indent. And then out here there's this except value error as, and we're just going to call it something. And we can just print that. And then we can say print could not calculate heart rate info. New line. Why do you want two new lines? I don't know why. So this should be this should be that, and this should be calculate. Calculate. Art info. And let's see, I gotta make sure I leave it. I gotta make sure this is over at 11:30. Okay, so there's that exception. And I'm also gonna put in an exception for, what was the name of that exception? What was the name of it? I wanna see what this exception was again. EF, this error. Okay, so let's see if that works. I don't know. I don't know what I'm doing right now. All right, let's see what this does. Okay, what does this do? Nice. What do you think about that, huh? So I you know, trapped this error, and I said, all right, okay, okay. So anyway, I think you might have enough to do this problem. Okay, you just got to take this stuff out of there. Okay, so what's next? It's 11:24. Let's take a look at this one. Handling to detect input string versus error. Okay, so what are we gonna do? Reads a single list of names and ages. Outputs a list of age with each age, and program fails, throws exception, and second input on a line is a string rather than a add fix me code, and try and accept blocks to catch the value and output 0 for the age. Okay, so when we run it, it looks like this. Is that, maybe that's true? And what we want to do is we want to throw in a try except, and so it's not going to cause an error. Okay, so let's see what happens. I'm going to put this there. Copy. I'm going to put that here. Paste. And I'm going to then, maybe I won't do that. And then I'm going to run this. Or I can just run this and see what happens. And it goes boom. Yes. And if I don't have that there, you know what, it works. All right. Oh, great. Okay, it works. Trouble is when Beth is there, there's a problem. Okay. Boom. Doesn't even tell me what Lee and Lua's was. Okay, so so we got to do a try catch thing. Try that, and otherwise, I don't know, set age equal to 0. Is that what we're supposed to do? Oh, yes. Oh, yeah, okay. Okay, so age equals 0. Okay, so it reads the parts, splits it. 0 is the name, and if that's not -1, it takes the first one and tries and thinks that's the age, and then it's 1 to it. And I'm supposed to do this. Is that right? I guess so. Could check to see if there's a parts too. But anyway, yeah. Does this do it? Oh, no, that's not quite right, is it? Okay. Anyway, no, it's not quite right. You can fix it. Okay. All right. So I've covered chapter 10, and it's exceptions are nice. And usually I don't know. I don't put it. I don't put exception handlers in any of the code I write. I guess I just do the I guess I just check the code and I don't know, make it more robust. But I started coding in the 70s, so I'm not used to these things. But exception handlers, and I read a lot of code. But anyway, these days it's a clean way of handling those cases where the user is not cooperating, or a case that you didn't even consider in your programming code. And so anyway, so that's it for chapter 10. And next week we'll start on chapter 11. Please go to, I changed the URL. I changed, so please keep up to date when you sit in this class. Let me just share my screen one more time here. Please keep up to date. Please keep up to date when you can sit in this class. So what I did was I registered the domain name because I wanted to be able to get it on my phone, and last name was so high. So I registered cansit.in, can sit in. And so that's the URL now. And when you look at this, what it turned out for this week, it looks like this, teaching this day, and then these are my other classes down here. And so I'm going to do this again next week, and I hope this works out. If you are out there and you really would like to attend a class, and you keep getting shoved off into one of these poor souls here that I wasn't able to schedule the time and they're being excluded, just let me know, and I'll make sure that if you send me that you want to show up for a class, and then something comes up and you don't show up, that's okay. I'm not going to check anyway. So, but anyway, have a good week, and I'll see you next week.
Thank you.
Thank you. Thanks for watching.